Pharmaceutical products approved in food-producing animals come with warnings that state for how long milk must be withheld from human consumption or what the wait time should be before animals are sent to slaughter after treatment. These are called withholding times or withdrawal times, and in this module we will examine the factors that determine how long these should be. Here's the formal definition of a withdrawal time, which is the time required after dosing for tissue concentrations of a drug or one of its metabolites to deplete to less than a specific concentration in a target tissue that has been established as indicating that residue levels in the animal's edible tissues are safe for human consumption. The factors that determine the length of the withdrawal time are 1. The initial concentration of the drug or its metabolite in the target tissue, which in turn is dependent on the dosing interval, or duration of treatment. 2. The rate at which the drug or its metabolite depletes from the target tissue, which we call the tissue half-life. And 3. What the specified concentration that is considered safe is, which we call the tolerance in the US, or the maximum residue level, or MRL, elsewhere. Let's first focus on what determines the value of the tolerance, or MRL. First, we need to know what is the no observable adverse effect level, or NOEL, for oral exposure. The NOEL is defined as the oral dose of a drug that results in no toxic effects in laboratory animals as measured in various experimental studies ranging from acute to chronic, as well as studies to specifically test carcinogenicity, reproductive, and microbiological effects. From the NOEL, an acceptable daily intake, or ADI, is set, which is the total dose of a drug that an average human could ingest on a daily basis for his or her entire life with no adverse effects. The ADI is commonly several orders of magnitude lower than the NOEL to account for the numerous uncertainties associated with extrapolating data from laboratory studies to humans, including interspecies differences and the longer lifespan of humans. Here we see an example of how the ADI is calculated from the NOEL. First, the NOEL is divided by a safety factor of 1,000 in this case, and then it is multiplied by the body weight of an average human to give 60 micrograms per day. Once we have the ADI, we can calculate the safe concentration of total drug residues, parent drug and metabolite, in various edible tissues by considering the amounts of the different tissues consumed in the typical diet of the target population. So, for example, if the ADI is 60 micrograms per day and a typical American eats 300 grams of red meat a day, then the safe concentration for total residues of the drug in meat would be 0.2 micrograms per gram of meat. Finally, because testing for total drug residues in tissues is rarely practical, regulatory authorities choose one compound as a marker residue, which can either be the parent drug or one of its metabolites, to calculate a tolerance, which is used to enforce the withdrawal times and identify milk or carcasses with residues that are higher than considered safe for human consumption. Once again, an example. This time, a marker residue, that is a metabolite, constituting 50% of total residues. In this case, the tolerance would be 0.5 times the safe concentration, or 0.1 micrograms per gram of meat. So, to summarize, the withdrawal time is the time needed for the marker residue to deplete to concentrations that are below the tolerance in the target tissue, which is usually the tissue from which the marker residue depletes the slowest. We'll talk a little bit more about this depletion rate in the next lecture.